1, you can use, but you don't need to have 0 to 1. Okay, if you have a lattice, maybe an unbounded lattice, it suffices that you place in the lattice a mapping reversing the order of the lattice, the order given by these operations. If you have an order reversing that, automatically you have a transitive reversing system. The intersection is a type 1, the union is a type 2, and you can be sure that you have a skewed middle and non-contradiction principle. What is an ortholattice? An ortholattice, you have 0 and 1, and you have, of course, this and this. I show you that this implies our principles. What if you have a De Morgan algebra? Why? In the De Morgan algebra, the complement, the prime, the negation, is not a complement, it's a pseudo-complement. What means that? That means that it is not always neither that nor that. But if you cannot say that the De Morgan algebra verifies non-contradiction and exclusivity in the modern sense, you are sure that this is a type 1 transitive reversing system, and this is a type 2 transitive reversing system. Then, in the interpretation of impossibility of self-contradiction, the modern algebras also verify the two Aristotle principles. In the books I look at logic, usually, they only are worried by non-contradiction, because as they always suppose the modern laws, duality, one implies the other. What in our very tiny structures? Well, if you have a transitive reversing system in which, what's this? The dual operation is a type 2. You only need to be sure. You only need this. If you have a type 2 and you have the reverse law, then with the dual operation you have a type 1. Then with this idea moving from one operation to its dual, of course, if the negation is strong, a type 1 operation, an operation is type 1, if and only if its dual is type 2. Then in the case of a strong negation, is absolute equality. This is type 1 if its dual is type 2, and this is type 2 if its dual is type 1. There is just a one-to-one correspondence between non-contradiction and excluded middle. This is the classical case. Imagine that you have an operation, then it's very easy. Look, I don't say it's type 1 or type 2, but if this operation verifies an Aristotle non-contradiction, the dual operation of that verifies excluded middle. If this verifies excluded middle, the dual verifies Aristotle. Look, this theorem is out of the type 1, type 2. Remember that the arithmetic sum is neither type 1 nor type 2, but verifies non-contradiction and excluded middle. Then this result refers to that kind of operation. Of course, when the negation is strong, then an operation verifies non-contradiction if and only if its dual verifies excluded middle. This last is the classical case in logic. But we are going to fuzzy logic. And fuzzy logic are not numbers, are not the elements in L, are functions. What happens when I extend everything to a set of functions? Well, it's not very difficult to establish. Imagine, let me say, first inside L and out of L. Imagine that this operation is a type 1. If you take an operation that is below this operation, this is also type 1. Hence, if that verifies non-contradiction, that also verifies non-contradiction. In the same idea, you have a type 2, and you take an operation of which the one you take is below, then if this is type 2, this is type 2. Hence, look, that independently of if the operation is type 1 or type 2, this is motivated because the the theorem I show you is not a characterization, just shows sufficient conditions. And we can work with operations that are neither of type 1 nor of type 2. And independently of the type of operation, if this verifies that is a correspondence between the operation and the two. Oh, take another time the unit interval. Take another. Now take any reverse order reversing mapping, not 1 minus x. The minimum give a cost, give a transitive reversing system with any order reversing operation. This is a transitive reversing system of type 1, and the maximum give a transitive reversing system of type 2. Of course, this verifies non-contradiction, and this verifies square middle. Are dual operations with any. No, it's not sure. If this is not strong, it's not clear that minimum and maximum are dual. It should be strong. Here I don't need the strongness of nothing or anything. Well, if you take any operation below min and any operation greater than max, of course, this is type 1, this is type 2. This is the case of T norms and T norms. Because any T norm is below minimum and any T norm is greater than maximum. Then practically you have a problem with acidosis solvent. And we need functions, of course. Well, it is true. It is true. I said that below minimum and greater than maximum. What if this is not the case? For example, what if I have an operation between min and max? I have not a clear result. For example, you know, with arithmetic mean, neither people 1 nor people type 2, but the two principles. With this operation, provided this is not 0, that is also between min and max, that this is a type 1, of course verifies it, but with the dual operation, of course you have a type 2, verifies that, but with that operation is between, you have not type 1, but it verifies also non-contradiction, and of course the dual operation is that it's not a type 2, but verifies in the middle. Then what with the other operations, comparable, not between min and max? Well, I did not study the case, but I don't know the solution. But imagine that you have an operation that is not between, not below, not greater. I don't know what happens. But this operation, if is no one of these cases, is not of type 1, is not of type 2, it neither verifies non-contradiction, not exclusion. I suppose that these operations will not work well, but I never studied this. Let me go to the functions. I have an empty set X, and I consider a set of functions from X to N.